Hello, welcome back to another episode of Math with Haas. You're watching Precalculus Season 2, Episode 25. We are continuing our investigation in trigonometry, and now we're going to start talking about right triangle trig. So, we've learned previously using just any old circle, but in particular we focus our attention with the unit circle. If we had a point on a circle, comma xy, we know that we have a radius here, r, and we could imagine that we draw a nice line going straight down. That's rather crooked. Let's try again. Here's our nice line straight down. So we can imagine now a triangle such as this. Now, because of where the x and y coordinates are, we know that the length of the base, that nice green line there, has to be a distance of x from the origin, and then that nice blue line going up from the positive x-axis to the circle, that is a height of y. And this triangle, since x and y are at a 90-degree angle, is hence a right triangle. And we can see the relationship between x, y, and r. In fact, if our circle is centered at some hk, so centered at the point hk, we knew that the equation of the circle was x minus h quantity squared plus y minus k quantity squared equaling r squared. For the unit circle, it was centered at point 0, 0, and r was equal to 1. So we had x squared plus y squared is equal to 1. So now when we think about trigonometry, right? We did trig on circles such as this here, but now we're going to consider circles centered on 0, 0, but radius can be something other than 1. So now the question is this situation here. And if we recall, our first definitions of sine, so here's our angle theta. We define sine theta to be y over r, cosine theta to be x over r, and from there we define the other four trig functions. So tangent theta was, we said sine over cosine, so sine theta over cosine theta, which was the same thing as y over r over x over r, which is the same thing as just y over x. And cotangent theta, we can similarly obtain x over y. Secant theta was 1 over cosine theta, which means it's just r over x, and that leaves cosecant theta to be y over r, since it is 1 over sine. Now, this gives us the relationship between our 4 or our 6 trig functions and the sides of, notice, a triangle here. So let's zoom out a little bit so we can see that. So all 6 of these trig functions we define in relation to the as ratios of the sides of this right triangle. And so we can talk about right triangles and how to find sides and angles. So there's a colloquial way of expressing this. So if we have a right triangle and some angle theta, this side over here, that's the height, oops, no, that is usually called the opposite because it is opposite from our angle here. It is literally across the way from this angle, so it's opposite. This one here is called adjacent because it's right next to our angle. And we leave this one as the hypotenuse. I wonder if I spelled that correctly now, as I think about that. Alright. So, apparently I did spell it correctly. Alright. I just verified through Google. Alright, so, back to this. So, when we think of it in this manner, we can say that sine of this angle, I'm going to abbreviate these, OPP for opposite, ADJ for adjacent, and HYP for hypotenuse. Sine, we'd say, is opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is going to be opposite over adjacent. Cotangent theta is equal to adjacent over opposite. Now, where we are getting these from, in case you missed the point, pun intended, is that when we think about our triangle up here, right, this r is the same thing as hypotenuse. So r is equal to the hypotenuse, y here is equal to opposite, and x is equal to adjacent. So what we're doing is essentially taking these these definitions that we originally discovered with the 6 trig functions, and now we're reinterpreting them under these names of hypotenuse, opposite, and adjacent. So that's what's going on down here. Once we make this connection of identification between x, y, and r with adjacent, opposite, and hypotenuse, we get this here, and it's actually very, very useful. So secant theta is going to be hypotenuse over adjacent, and cosecant theta is hypotenuse over opposite. Now, the way we want to think about this then is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, and these three here form the following mnemonic device. I feel like I just butchered saying that word, but whatever. So sine, we said, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You pretty much cannot escape trig without coming away with this memorization device, SOH-CAH-TOA. SOH-CAH-TOA, so S, sine, O for opposite, H for hypotenuse, CAH, cosine is adjacent over hypotenuse, TOA, tangent is opposite over adjacent. SOH-CAH-TOA is a great thing to memorize, and it will help you keep track of which sides of the triangle go with which trig function. So now we can actually already work out some examples. So if I have this triangle here, for example, oops, let's see here. Let's make this 5, 15 theta. Alright. So if I wanted to find, say, tangent theta, we're told it's opposite over adjacent. So that's literally 15 divided by 5, which is 3. If we wanted cotangent theta, you could work it out as 15/5 and get your 1/3, or you could have just remembered that cotangent theta is 1 over tangent theta, which is 1/3. Either way, you get the same thing. Now if we want to figure out what cosine theta is, Well, it's adjacent over our hypotenuse. We have to figure out what the hypotenuse is. So we can use Pythagorean theorem, a squared plus b squared is equal to c squared. So 5 squared plus 15 squared equals c squared. Well, let's see here. 5 squared is 25. 15 squared is 225. Let's double check that. 15 squared. Hooray. Let's add 25. And let's see here. Does that square root nicely? I doubt it. And it definitely doesn't. So c squared. So I'm going to say c is going to equal just square root of 250. I'm not going to use that decimal value. You don't want to use the decimal value because in general you want to find the exact value. So if you use just 15.8, you're really rounding, and we don't like rounding. So to avoid that, we're going to use square root 250. So square root 250. So cosine theta is 5 divided by square root 250. And now we can, depending on your instructor, you'll have to rationalize the denominator. So this is root 250 times root 250 over root 250. We gotta move over a little bit more. This is equal to 5 root 250 over 250. Note, since this number in denominator ends in a 0 or a 5, in this case it's a 0, it's divisible by 5. So let's find out. 50. So this is the same thing as root 250 over 50. Cool. And this tells us also that secant theta, which is 1 over cosine theta, if we just use this quantity here before we did all of our simplifying, then we wouldn't have to rationalize the denominator again. We just figure out, well, it's the reciprocal of this thing. So that's the answer for cosine, or for secant. Now we got to figure out what sine is. So let's look up here. So we have sine theta is equal to 15 over 250 square root. Alright, so then this we need to rationalize again. So that is going to be, if we note 15 is 3 times 5, that means we're going to have a 3 root 250 over 50. Reason being is because we found out that 5 divided by 250 was 50 over here, so no need to redo that work. And we can note that 50 is not divisible by 3. The reason why we know that is if you take the digits of a number, add them up, in this case 5 plus 0, you get 5. Then if you take 5 divided by 3, if that doesn't give you a nice integer but some decimal, like in this case it would, because that's 1 2/3, you know it's not divisible by 3. We could do the same thing with 250. 2 plus 5 plus 0 is equal to 7, not divisible by 3. However, if you're wondering about 111,111, that's equal, if we're interested in this number, right, you can just do 1 plus 1 plus 1 plus 1 plus 1. So let's see, that's 5, that's 6 ones. That's equal to 6. 6 is divisible by 3, so 111,111 is divisible by 3. If you don't believe me, divisible by 3, boom. See? Beautiful. Now notice 37,037, that adds up to 20, not divisible by 3. See? Boom. Awesome technique to keep in mind. Alright, coming back. Since sine is equal to this quantity, we know cosecant, since it's 1 over sine, has to be root 250 over 15. Alright, so that is just working through SOH-CAH-TOA, finding the different values. Now, we can ask ourselves a new question, right? So we know that's 90 degrees, that angle there. But what does theta equal? In fact, let's call this one phi. How do we find theta and phi? So, if we want to find theta, we know that cosine theta is equal to, what did we say, 5 over square root 250. Doesn't really matter if you pick this one here or this one here to work with, same thing. So what we learned previously is that we can use the inverse trig functions. So if we take arc cosine of cosine theta, this has to equal the arc cosine of 5 over root 250. So what you do to one side, you have to do to the other. And in general, when we do right triangle trig, we want our answers in degrees. So I'm just switching my calculator over to degree mode. Now on the left side, the inverse and the cosine will kill each other off. So theta is going to equal the arc cosine of 5 over root 250. So arc cosine, so I hit second and then cosine, because you see that cosine is 1 right above, tells you you have to hit the blue button first. So 5 divided by second square root 250 gives you 71. So theta is approximately 71.57 degrees. We'll just go to decimal places. So since we're dealing with a right triangle, we could have, before I move on, in general, you want to use sine, cosine, and tangent. Those are the three functions you want to use to find theta if you're interested in finding that angle. You don't use cotangent, you don't use secant or cosecant, because for one, you have to do the inverse of those functions, and practically speaking, those are not programmed on here. In fact, you don't really need to use those, because you can take any of those three quantities and figure out what they are in terms of sines and cosines and tangent, and then just use these three functions. So do not use like arc cotangent to find theta, just use the inverse trig functions for sine, cosine, tangent. The other thing to note is, since we have a 180 degree triangle, or all triangles add up to 180 degrees, and since we have a right triangle, that means that theta plus phi equal 90 degrees, because the third angle is already 90 degrees. 180 minus 90 is 90. So if we want to find phi is going to equal 90 degrees minus theta, or just 90 degrees minus 71.54. So if we ignore the negative, we know that phi has to be 18.43 degrees. I just took our answer previously and subtracted 90. So if we want the correct answer, we have to multiply by -1, but whatever. Alright. So this goes over pretty much finding everything. You can, if you're given one angle at one side or two sides, then you can find anything that you want about the triangle. That's of course excluding the fact that it is a right triangle. So if you're given, so it doesn't matter if you have given one angle or and one side or just two sides. In either case, if you're given that much information, it's sufficient to find everything else there is to know about that triangle in terms of angle measurements and lengths of those three sides, as we kind of saw here. Let's see. Now let's go ahead and do a nice word problem. Let's see here, where did that word problem go? Here is our nice word problem. Alright. So, example. Alright. There we go. So, there is an antenna on top of a building from a location 300 feet from the base of the building. The angle of elevation to the top of the building is measured to be 40 degrees. From the same location, the angle of elevation to the top of the antenna is measured to be 43 degrees. Find the height of the antenna. Okay, so whenever you do word problems like this, we should draw a picture. So let's see here. Here's our building. Here is our awesome antenna. Okay, and then we got some dude here. So this dude, we're told, is 300 feet. So that's this quantity here. Alright. So, from a location 300 feet from the base of the building, the angle of elevation to the top of the building. So, let's note this was the building. And I just screwed that up. There we go. So, here is our nice. So, it says the angle of elevation. So, angle of elevation means from some nice horizontal line, we're going up above it. So elevation, just think we're rising. And let's see. So just note elevation, angle is going up. And if there's a angle of declination or depression, that means it's going below the horizontal line. So in this case, this is our horizontal line. We know this is 40 degrees. And then from the same location, the angle of elevation to the top of the antenna, right here, this is 43 degrees. Cool. And the question is, what's the height of the antenna? So let's get a new color. So this is what we're interested in right here. And I'm going to just use an H for height. Alright. So, looking at this, we have two triangles here, right? So, if we go back here, we have this nice blue triangle. Let's clean this up a little bit. So this here is, I don't know, we'll just call it Y, why not? So Y, we'll say, is the height of the building. We know that we have an angle of 40 degrees and that this is 300 feet. Now, what we're interested in is this triangle here, where we have a same base, but our angle here is 43 feet. And when we think about the height of this triangle, it has to be this entire thing here, right? So that's y plus h, y plus h. And we want to know, what does h equal? Right, so that was our goal. What does h equal? So the first thing we needed to pay attention to is the fact we have two triangles. So, oh, that's funny. I put degrees here when that should have been feet. That's funny. And it looks like I'm missing my t over here. So when we look at this, we can use trig to figure out what y plus h is, and we can use trig to figure out what y is, right? So looking at this, this is we're given right here is adjacent, right here is adjacent. We are interested in this quantity over here. In fact, we're interested in particular what h is, but annoyingly we have to know what y is. So we can use the red triangle to figure out what y plus h is using trig. But since we're interested in y itself, we need to subtract y from h. That means we have to look at the blue triangle to figure out what y is. Okay, so our strategy is going to be figure out what y is, so that when we figure out what y plus h, we can subtract y from it and get our quantity h by itself. So that's our plan. So in both cases here, we're interested in this quantity that I boxed, and that is opposite from our angle. So let's see, let's work this out now. So we're given opposite and adjacent. That tells me tangent. So setting this up, tangent of our angle, 40 degrees, is equal to opposite over adjacent. So if we solve for y, y has to equal 300 times tangent of 40 degrees. All we had to do is multiply both sides by 300, and we got y by itself. So 300 tangent 40. Note, calculator's in degree mode. So this tells us the height of the building is equal to about 251.7 feet. Now what I'm going to do is hit the stow button. I'm going to store this in this. I'm going to hit alpha and A, so that's stored in memory slot A. Very useful. That means if I just hit A, there's my number. It's almost magic. Alright, so now we can do the exact same thing. We have opposite and adjacent and an angle, so that tells me use tangent. Tangent 43 degrees is equal to opposite over adjacent. So that tells me y plus h has to equal 300 times tangent of 43 degrees. So let's figure out what that is. 300 tangent of 43, enter, boom. So y plus h is equal to 279.75 feet. Now, our final step is we just need to subtract y from both sides, right? So h is going to equal 279.75 minus 251.7. So I'm going to take this value and subtract 8. So notice I was just kind of playing loose with rounding conventions on the work, but on the actual work in the calculator, I'm using all of the decimal places because I use the memory slots for storing values. So keep that in mind. And now we'll be careful with our rounding. So we got 0.0, we'll just round down 0.02 feet. So there's the height of our antenna. Cool. And one thing to note, this actually needs to be approximately, right? Because it's not the exact value, it's a rounding. Alright. So with that, we're going to conclude this episode of Math with Haas. If you've enjoyed our content, please consider subscribing and supporting us on Patreon. Your support means a lot to us and helps me be able to produce more videos. Alright. Thank you for joining our math party, and I will see you next time.